Hello friends, welcome back to Mana CS Classroom. In our previous videos, we learned what arrays are, array declaration, memory representation, initialization, traversal. Now imagine a situation, you already stored marks of students in an array. Suddenly one more student joins the class and writes the exam. Where should we store that student's marks? How can we add a new value into an existing array? This operation is called insertion. In today's video, we will learn insertion operations in arrays with examples, diagrams, algorithms and C programs. So let's get started. Suppose we already have some values stored in an array 10, 20, 30, 40, 50. Now we want to insert 25. Can we simply place it anywhere? No. If the data must remain organized, if the data must remain sorted, this 25 should be placed between 20 and 30. This means some existing elements must be moved. This is exactly what insertion operation does. So array insertion can happen in different ways. Case 1, adding at end, insertion at end. Case 2, adding an element somewhere in the middle, that is insertion in the middle. And case 3, adding an element into a sorted array while maintaining the order. So let's understand each one. Insertion at end. This is the easiest type of insertion. Suppose an array currently contains 4 elements and it has a free location available at the end. Let us assume we have an array with the maximum size 5 and which has already 4 elements accommodated 10, 20, 30, 40. Now we want to add one more element, insert one more element 50. So we simply place that new value in that freely available location. No shifting is required, hence insertion at end is very fast. So if you look at the algorithm, to insert at end, first increase the upper bound. Suppose if previously you had 4 elements or if your index value is 3, then you need to increase your index value to 3 plus 1, that is 4. And into the newly increased upper bound, you need to place your new value. Okay. Suppose previously we had elements at index 0, 1, 2, 3. Fourth index is freely available. Your upper bound was 3. Now increase upper bound. Example 3 plus 1 becomes 4. Okay. And at the fourth index, you insert your new value. So A of 4 is your new value. For example 50. And then exit. That's all. Very simple operation. Time complexity is just order of 1. You are not shifting any elements and you are not repeating or iterating anything. You are not traversing through any loop. So time complexity is just a constant time. Okay. And here we must notice one thing here. Memory space allocated for the array is still available. So if there is a free location available, then only we are talking about all these insertions. Insertion at end, insertion in the middle, or insertion in a sorted array. So this note is to be remembered throughout all the insertion operations. And next comes insertion in the middle. Now let's look at insertion in the middle. Suppose we want to insert 25 into an array which already has elements 10, 20, 30, 40, 50. So 25 should be placed between 20 and 30. But 30 already is occupying that location, right? 30 is already occupying that location. So we need to create a space first. So I'll show you an array by drawing boxes 10, 20, 30, 40, 50. Let us assume there is a free location available at the end of the array. But we want to insert 25. As per the order, 25 goes between 20 and 30. That means after the element 20, 25 comes. but here already 30 is occupying this location. So we need to ask 30, please scoot over. So please 40, please scoot over, and 50, please scoot over. So we need to ask all these elements to shift one position right. So we move elements from here one position to right side. Only after creating space, then we insert the new value. So this is very important concept. So how to shift these elements? Let us again draw the array 10, 20, 30, 40, 50, and there is a free location available here. So this is our array and we are trying to insert a 25 after 20. So in which order we need to shift the elements? So first, do I need to shift 50 or first do I need to shift 30? So after shifting 30, then I shift 40, then I shift 50, or first I shift 50 and then I shift 40 and then I shift 30. Okay. So the correct method is move from the end. That means we first shift 50. So 50 comes here. Then this location gets emptied and then we shift to 40. Okay. Then this location get emptied and then we shift 30. So 30 comes here. There this place gets vacated, emptied, vacant. Okay. So there we need to insert 25. So I'm starting from here right and going towards the left. So you start from right and go towards the left. So that is the correct order. If you do not follow this order right to left, then elements will be overridden. Okay. So I'll again draw the array 10, 20, 30, 40, 50 and there is a free location. Suppose if I start shifting from 30, then if I shift 30 to 40, then 40 will be overridden by 30. Okay. Then again I shift this element here. That means again 30 will be copied here. Then again if I shift the element here, then again 30 will be copied. So your result will be disturbed and you will get the incorrect result. So please remember, it is very important concept. We start shifting from right and move towards the left. So if you do shift from left to right, you may overwrite existing values and lose the data. So therefore insertion always starts from last element. That is why shifting is performed from right to left. So many university exams ask this question. There we see the algorithm to insert in the middle. So this algorithm follows exactly the same idea. Start from the last element, okay, and shift every element one position to right. So that means you are shifting a of I to a of I plus 1 position. You are shifting it to right location. Create an empty location and insert the new value. Increase the size of the array. So after you place your new value, your size of the array will be increased. It was previously n, now it has become n plus 1. Okay. Now we shall see an example. 12, 23, 34, 45, 56, 67, 78, 89, 90, 100. If you observe, the array is already sorted. Now we want to insert 75. So 75 should come after 67. After 67. And before 78, in between 67 and 78. So all elements from 78 onwards are shifted one position to right. Then 75 is inserted. Okay, then only the array remains sorted. So what we need to do, where do we start? Do we need to start from 78 or do we need to start from 100? We always need to start from last element. Last element, shift it to one position right and then come to the next one. You move towards the left side, okay? Then shift 90 and then shift 89 and then shift 78. There you get an empty location. Into that empty location insert 75. Okay, so that is how algorithm works. Now let us look at a program, C program. Write a program to insert a number at a given location in an array. So first we have declared all the variables which are required for us. I, N, number, the number that you want to insert, position, the position where you want to insert, the array. Okay, as we know, array must be declared uh, at the beginning of the function. Before the use of any variable, we must declare them. That is the C rule. Enter the number of elements in an array. We are asking how many elements are there in the array, and then reading that number into n. Okay, how many elements are there? We are just asking a user how many elements are there in the array. And then using a for loop, we are reading what are those. Suppose let us say I am saying there are 5 elements in the array. What are those 5 elements? Okay, what is array of 0? What is array of 1? What is array of 2? What is array of 3? What is array of 4? Okay, every element individually I am reading using a for loop. Here we must remember we must use ampersand in scanf. Next, I am asking user enter the number to be inserted. Okay, for example, let us understand 10, 20, 30, 40, 50 are there. Okay, 5 elements I already read from this for loop. Now, the number that I want to insert is 25. I want to insert 25. Enter the position at which that number has to be added. So in which position you want to add that number. If I want to keep this sorted order in the array, I just need to enter this 25 in the third position, right? Okay, so I need to enter the third position, or according to the index I need to enter in the second index. I want to insert this 25. Okay, and as per our discussion, where do we start shifting, from the right side or the left side? We always start shifting from the last element. Okay, so here for loop starts from n minus 1, and you shift all the elements till you reach that particular position. Okay, so I greater than or equal to position I minus minus. As you are coming in the reverse direction, you need to decrement I variable. If you go in a forward direction, you will always increment the variable, but you are coming in the reverse direction, right? You are starting from the last element and you are shifting one by one element to the right side. That is why, so you need to decrement I minus minus. And how do we shift? We take one element and we shift it to right. We take one element and we shift it to right. That means I to be shifted to I plus 1. So a array of I to be shifted to array of I plus 1. Okay, then when you reach position, this loop will be exited. This loop will be stopped. We will exit from this loop. Now to that empty location, to that position, you insert your number. As per our example, 25 will be inserted into the given position. Now after inserting 25, how many will be the total number of elements? Previously it was 5. Now it will become 5 plus 1, 6. Okay, total number of elements is equal to 6. So what is the array after insertion of 25 is I is equal to 0, I less than n, I plus plus, display all the elements. So your output will be displayed as array of 0, 10, array of 1 is 20, array of 2 is 25, which is newly inserted element, array of 3 is 30, array of 4 is 40, array of 5 is 50, like that. Okay. When the array is already sorted, that is the third case in insertion into an array, insertion in sorted array. When the array is already sorted, we first find the correct position. Then we shift all larger elements one position to right. Finally, we insert the new value. This preserves the sorted order. Okay. So if you see 1, 2, 4, 5, 6. I already have 5 elements in my array. They are 1, 2, 4, 5, 6. Now I want to insert 3. Okay, so we start comparing from the last element 6. So 3 is less than 6. So 6 has to be shifted right. Then again I need to compare with the next element. 5 is still larger than 3. So 5 is to be shifted right. And then 4 is still larger than 3. Then 4 is to be shifted right. Then 2 is smaller than 3. There I will stop. Okay. So this will be like 1, 2, and here is an empty location 4, 5, 6. Here I'll get the empty location. Into this empty location I need to insert 3. The same concept. Previously how did we move? Starting from the last element and to the right we shifted the elements. Here the concept that we need to do, extra thing is that we are doing, we are comparing. So this element and this element, if it is greater, then we are shifting it. If it is less than, then we do not shift, we stop there. If this element, if the array element is larger than the new element, then we need to shift. Okay, 6 is larger than 3, so we need to shift 6. 5 is larger than 3, so we need to shift 5. 4 is larger than 3, so we need to shift 4. 2 is not larger than 3, so stop there. There you will exit from the loop and you will get the position, required position, and into the required position you need to insert the element. The resultant array is 1, 2, 3, 4, 5, 6. End. So insertion at end is very fast because no shifting is required. So its time complexity is order of 1. Insertion in middle requires a movement of several elements, and we always take the worst case, that is upper bound, right? I hope you have gone through the video of big O notation. So big O always takes the upper bound, the maximum. For example, your university exam time duration is 3 hours. Okay, so any student can last for 3 hours, can stay for 3 hours. The maximum time limit is 3 hours. So we take the worst case. So n number of elements are to be shifted. If n number of elements are to be shifted, the order of n. Insertion at middle time complexity is order of n. And in the worst case, almost every element must be shifted. Therefore, the time complexity becomes big O of n. Insertion in the sorted array also, time complexity is big O of n. As I told you, we always take the worst case. So in the worst case, for example, I want to insert 5 in the array 10, 20, 30, 40, 50. I just want to insert 5. As per the sorted order, I need to shift all the elements 50, 40, 30, 20, 10. There I get the required position. So mostly all the elements are to be shifted in the worst case. That is why insertion at the middle and insertion into a sorted array, both operations take the time complexity of big O of n. So let's summarize. Insertion is the process of adding a new element into an array. Insertion at the end is easy. Insertion in the middle requires shifting. Shifting always happens from right to left. Sorted arrays require insertion at the correct position by comparing the elements. Again, from the last element you need to start comparing. The worst case time complexity is order of n. So friends, today we learned insertion at end, insertion in middle, insertion in sorted arrays, insertion algorithms, C program, time complexity. In the next video, we will learn the opposite operation called array deletion, where we remove elements and shift the remaining elements to fill the empty space. If you found this video useful, please like, share and subscribe to Mana CS Classroom. Thank you for watching. See you in the next video. Happy learning.